Hello everyone, I am going to attempt to make video notes from home. My whole family is home with me, so you might hear them in the background. I hope it's not too distracting for you. I wanted to upload these notes for you so that way instead of uploading someone else's notes or someone's notes that I found online, I'd like to do them for you. Since we are getting into a new section, we are going to factor out the greatest common factor monomial from a binomial. That sounds like a lot of math gibberish, but mathanese, and I am your translator. So here we go to my lesson, but before we start, I wanted to show you my setup. So here is my stand with my books that hold my stand, and I'm going to be doing it on whiteboards. So I know I'm no Sal from Khan Academies, but please bear with me and your patience is greatly appreciated. So on to the lesson. Let's see. All right, so the first thing I want to do is start off with review, distributing by multiplication. So if I have 2 times the quantity of 3x minus 1, then I'm going to take this 2 and distribute it to both terms. 2 times the first term of 3x is going to give me 6x. 2 times the second term of negative 1 is going to give me negative 2. And this is the product of those polynomials. This monomial, excuse me, times this binomial. Now let's do it again with this problem right here. I have 3x squared times the quantity of 2x plus 5. So I'm going to take the 3x squared and distribute it to both terms. 3x squared times 2x, well 3 times 2 is 6. And x squared times x is x to the third. Remember, when you multiply variables, you add the exponents. And even though you don't see it, there is a exponent of 1 there. Now I take that 3x squared and I distribute it to the second term, 5. 3x squared times 5 is going to be 15x squared. And this is the product of those two polynomials. This monomial times this binomial. And the reason why we're reviewing this is because this section that we are going to start, it starts off with this form, this standard form. And we are going to take this form and put it into factored form by taking the greatest common factor monomial and dividing it from each term. So if you think about distributing by multiplication to each term, factoring is like dividing each term by that greatest common factor. So for instance, if I were to take this 6x third plus 15x squared and I divided it by that 3x squared each term, so just like you distribute to each term, you factor each term, which is kind of like divide. Well, let's see what we got. 3 divided by 6 is 2. X to the third over x squared. Well, that's your exponent rule of 3 subtract 2 gives you x to the first. Plus 15 divided by 3 is 5. And x squared over x squared cancels to positive 1. So what I'm left with is what was inside these parentheses. And what I divided is that greatest common factor monomial. So we're taking it from this term and putting it into factored form. So let's go and talk a little bit more about what a greatest common factor is. Let's review what that means. So the greatest common factor of two numbers. So if I were to say, what is the greatest common factor of, let's say, 16 and 24? So if you want to find the greatest common factor, you just don't want any common factor. 2 is a common factor of both 16 and 24, but it's not the greatest common factor. So by listing out each set of factors for each number, you can find the one that is the biggest, the greatest. So the factors of 16 are 1 and 16, 2 and 8, and 4 and 4. 24 has factors of 1 times 24, 2 times 12, 3 times 8, and 6 times 4, 4 times 6. So now I look at both of these list of factors. They all these factors multiply to 24, all these factors multiply to 16. They both have 1. It's a common factor, but not the greatest. As I said, 2 is a common factor, but it's not the greatest. 4 is a common factor, but the greatest common factor of both these numbers is 8. So the greatest common factor of 16 and 24 is 8. Well, what happens if I add a variable, a couple of variables? What if I said, let's do a small number, 8x squared. Let's change that to 8x cubed. And let's say, we'll do 16x squared. All right, the greatest common factors, you probably already know what it is for the numbers, but this is more for the variables. So if I look at my common factors, I'm going to have 1 times 8 and 2 times 4. The x's can be expanded. X cubed can be expanded to x times x times x. The factors of 16 are 1 times 16, 2 times 8, 4 times 4. And x squared can be expanded as x times x. So the greatest common factor of 8 and 16, I'm looking for the greatest. So although they both have a 1, 2, and 4, their greatest common factor is 8. So far, I know that the greatest common factor monomial has an 8 in it. Now I look at these x's. This one has 3 and this one has 2. I need to be able to take out the same amount from both. I can take 2 from this one and 2 from this one, but I cannot take 3 from this one, which means the greatest common factor is x squared. So I can take out 2 x's. So the greatest common factor monomial of 8x cubed and 16x squared is 8x squared. So now let's apply that to some examples. Okay. So the first example I have is 12x squared plus 18y. And did I erased the first board, that's fine. So when I'm looking at this is standard form. I want to put it into factored form, which is always going to include a set of parentheses. The greatest common factor is going to go here. So this is the greatest common factor monomial. You're still going to have a first term and a second term every single time. So you're going to have these 3 positions every single time. So now I look at my first and second term. I'm looking at these 2 terms and looking for the greatest common factor. What can I divide out of both terms that's the biggest number? Well, first I look at 12 and 18. I'm going to figure out the common factors in just a second. But I notice the variables are x and y. I have to be able to take out the same thing from both terms. Since both terms do not have an x, I can't factor out an x. Since both terms don't have a y, I can't factor out a y. Which means in these 2 positions, first and second term, it's still going to have an x and a y. I can't factor out the x and y because they're not the same. So now to find the factors of 12 and 18. All right, so 1 times 12, 2 times 6, 3 times 4. 18. 1 times 18, 2 times 9, 3 times 6. Now I look at this list. Hey Audrey, do you mind turning that down? Okay. 1, 2, 3. The greatest common factor though is 6. So the greatest common factor monomial is 6. And like I said before, it's kind of like dividing both of those terms by 6. So again, I cannot take out the variables x and y. So 12x divided by 6 is going to be 6x. The addition sign still stays there to separate the 2 terms and nothing changed it. 18y divided by 6 is 3y. Did I miss something? 6 and 3 still have a common factor. Oh, oh. 2x. There you go. If we were in the classroom, you guys would have caught that a lot sooner. Sorry for the long pause. All right, so here we go to the next one. So this, this is the complete form. This is the greatest common factor of both these two terms was 6. So 6, if I were to distribute this back, I would get the 12x plus 18y. You can always check by distributing by multiplication. So now let's move on to the next problem. All right, so the next problem, 24x to the 5th minus 12x squared. So again, I know my factored form is going to have two sets of parentheses. My greatest common factor monomial goes here, and then my two terms. That's always going to be the case. All right, so now I'm looking at 24 and 12. You can kind of guess what it is, and as you're starting to do more and more of these, you will start to see the greatest common factor. But I'm going to list them out anyway. So 24, 1 times 24, 2 times 12, 3 times 8, 4 times 6. 12. The factors of 12 are 1 times 12, 2 times 6, 3 times 4. Now x to the 5th. 1, 2, 3, 4, 5. That's expanded. X to the 5th. X squared, x times x. All right, the greatest common factor monomial. What's the biggest factor that they have in numbers? So I'm going to say that they both have a 1, they both have a 2, a 3, a 4, a 6. But the greatest common factor monomial is a 12. And for their variables, I can only take 2 from both of them because this term has 2 and this one has 3. This one has 5, which will have 3 left over. So the greatest common factor monomial is 12x squared. So now I'm going to divide that from both of these terms, 12x squared. 12x squared. Okay, 24 divided by 12 is 2. X to the 5th over x squared, that's your subtraction rule. 5 subtract 2 is x to the 3rd. The subtraction stays between those two terms, nothing changed it. And 12x squared divided by 12x squared is 1. This is factored form of this binomial. We've got the greatest common factor and what is left over. All right, let's do it again. All right, here we go. Let's see your board. All right, 2x plus 2y. So again, factored form has a set of parentheses, the greatest common factor, and then the two terms inside. All right, what I'm looking at, I have 2x, and it's 1 times 2, and then an x, and 1 times 2, and then a y. So the greatest common factor of both of these terms is just 2. So the greatest common factor is 2. So if I look at both of these terms and I say, okay, if I'm going to divide the greatest common factor, which is 2, what do I get? Well, the 2 over 2 cancel and leaves just x. The plus stays there. Nothing changed it. 2 over 2 cancels and y is left over. Again, like the problem earlier, both terms don't have an x and both terms don't have a y. So you can't factor out. You have to be able to take it out of both terms. So this is our finished product. All right, the next one, 6x squared. Again, getting ready for my factored form. I'm going to have parentheses and 3 positions, greatest common factor. And then first term, second term of what's left over. All right, 6. 1 times 6, 2 times 3. X squared is x times x. 15y. 1 times 15, 3 times 5, and y. So I'm looking at both of these sets and I'm looking for the greatest common factor monomial. Looks like it's only going to be a 3, the greatest common, and there's no y's over here, no x's, so the greatest common factor monomial is just 3. So I take that greatest common factor and that's what I'm dividing each term by. 6 divided by 3 is 2, so 6x squared divided by 3 is 2x squared. The subtraction stays between the two terms. 15y divided by 3 is 5y. And all done with that one. All right, going a little bit quicker through these. I'm going to grab my next board. All right, here we go. Looking at the next one, I have 3x to the 4th plus 16x squared. All right, so I have my factored form with its 2 sets of parentheses, the greatest common factor, and my 2 terms. All right, so first I'm going to write all the factors of 3x to the 4th. 1 times 3 is the only factors of 3, and x to the 4th is 1, 2, 3, 4. 16x, well, there's more than just one set of factors. 1 times 16, 2 times 8, and 4 times 4. There's only one x. So in this one, notice that the only thing they really have in common for their numbers is 1. If it's just 1, you don't have to take out the 1. I'll go ahead and circle it. But they don't have any other common factors. But they do have one of the x's. So the greatest common factor monomial in this case is just 1x. You don't have to write that 1 in front. You can if you want to show that it's 1x, but if it's just the variable x, just go ahead and write x. So then that, again, since my greatest common factor monomial is just x, that's what I'm going to divide each of these terms by. So 3x to the 4th, and remember this has an exponent of 1, divided by x to the 1st, that's top subtract bottom. 4 subtract 1 gives you 3x to the 3rd. The addition sign stays between those two terms. 16x divided by x, well, the x's cancel. 1 subtract 1 is 0, which just leaves 16. So in this problem, we did not have a greatest common factor that was a number. The only thing the greatest common factor monomial was just a variable, and that can happen. Okay, let's look at the next one. The next one is going to be somewhat similar. So I have 5x to the 6th plus 2x to the 5th. My set of parentheses for factored form, greatest common factor, first term, second term. 5x to the 6th. The factors of 5 are 1 times 5, and that's it. So now I have x times x times x times x times x times x. All right. And 2, the only factors of 2 are 1 times 2. But x to the 5th is x times x times x times x times x. So again, for the numbers, for the greatest common factor in numbers, they only have that 1 in common, which means it's going to be similar to this problem over here where we're going to have just a variable. But this time, this term has 5 x's, this one has 6. So I can take 5 x's from this one and 5 x's from this one. That leaves 1 x over here. And if you've been noticing, when I circle this, not all the time, but this one is 5x is going to be left over and 2 is going to be left over. But x to the 5th is our greatest common factor. So x to the 5th, which means I'm going to divide that by both of these terms. All right, 5x to the 6th divided by x to the 5th. Well, that's going to leave me with 5. Top subtract bottom, 6 subtract 5 gives me x to the 1st. So I just put x. You can write the 1. It doesn't need to be there. The addition sign comes between our two terms. Nothing happened to change it. And 2x to the 5th divided by x to the 5th. Well, the x to the 5th over x to the 5th simplify to positive 1, which just leaves that 2. And this is factored form. All right, I got a couple more examples, and then that will conclude it for this lesson video notes. All right, so this one, 15n to the 3rd plus 25n. So again, we're going to get ready for factored form with the two sets of parentheses, the greatest common factor, first term, second term. So the factors of 15n to the 3rd, 1 times 15, 3 times 5 are the only factors of 15, and then we have n times n times n. 25n, 1 times 25, and 5 times 5. Those are the only factors of 25. And then we also have the n. So now I'm looking for the greatest common factor, which is going to be 5, and just one of the m's. I can only take 1 from this side. Even though this side has 3, I can't take 3 from this one. So then that means our greatest common factor that I can take out from both of those terms is 5n. All right, so now that I know what my greatest common factor monomial is, now I'm going to go to both of these terms and divide it from both terms. Okay, so 15 divided by 5 is 3, and top subtract bottom, this x variable does have an exponent, it is 1. So 3 subtract 1. So 15 to the n to the 3rd divided by 5n gives me 3n squared. The addition sign comes down between those two. And then I have 25n divided by 5n. 25 divided by 5 is 5, and n over n simplifies to positive 1, so this is the factored form of this standard. All right, here we go. 12a to the 5th plus 8a. So two sets of parentheses, greatest common factor, first term, second term. 12a. 1 times 12, 2 times 6, 3 times 4. And a to the 5th. 1, 2, 3, 4, 5. 1 times 8, 2 times 4, and that's it. And 1a. So I'm looking for the greatest common factor. I'm looking and I see 1, 2, and 4. I don't see an 8 in this side, so 4 and a. So the greatest common factor monomial is at 4a. All right, so now I'm going to take that greatest common factor and divide both of these terms, 4a and 4a. So 12 divided by 4 is 3. A to the 5th divided by a. So a to the 5th, top subtract bottom. This a does have an exponent of 1. 5 subtract 1 is 4, which becomes a to the 4th. 8 divided by, and this addition sign between the two terms. 8 divided by 4 is 2, and a over a simplifies to positive 1, which means this is our factored form. And I wanted to do one more example. I don't think I did one where we did one example where the entire factor goes out. For example, let's say if I had 24x to the 5th minus 12x squared. If I wanted to do this one, the greatest common factor of both of these is going to be 12x squared. And 1 times 24, 2 times 12, 3 times 8, 4 times 6, 1 2, 3, 4, 5. 1 times 12, 2 times 6, 3 times 4, x. So the greatest common factor is 12x squared. When you do this, and you divide both terms by that 12x squared, notice the second term is going to completely divide out. So the first term, 24 divided by 12 is 2. Top subtract bottom, 5 subtract 2 is 3, so that is x to the third. But notice 12 divided by 12 is 1. X squared over x squared is 1. So this all simplifies to positive 1. So that second term just don't leave it out. It is supposed to be there. So if it completely goes away, you replace that term with 1. All right, I hope you understood that. 26 minutes of notes of the same idea. If you have further questions, on this subject, please don't hesitate to request a Google Meet. I would love to talk about this all day with you. You know I love math and I miss you guys, so I wouldn't mind a little FaceTime if you have questions. Otherwise, I'm going to post this lesson up, or the assignment for these notes that I just made for you, as well as a quiz to follow it. So I'm also going to put the video or the worked out solutions on Wednesday. So I'll put the assignment out today. You'll have time to do it. Check your solutions on Wednesday. And then on the same day, Wednesday, I'm going to put the quiz up. You can take the quiz as many times as you would like. I will, as soon as you submit it once, I will send you a response back with a private message on which ones that you need to take a second look at. And then you can resubmit it and try again. Daddy. Be safe. Miss you guys.